In this video, we will be looking at the properties of real numbers. By the end of this lesson, you should be able to use the properties of real numbers to simplify expressions and justify those simplifications. So right now, we're going to take a look at what our properties of real numbers are. You may be familiar with some of these, but we will look at it in our context of algebra. So let's take a look at this one first, the commutative property. The description here says order does not matter, okay? So when we look at the commutative property, an example for addition, I'm just going to simplify that as add, is to think about 3 plus 2x squared is the same as 2x squared plus 3. Notice I changed the order of the 3 and the 2x squared on either side of the equal sign. The order does not matter for the commutative property. The order does not matter. If we look at an example for multiplication, we have 8 times the quantity of x plus 2 is the same as the quantity of x plus 2 times 8. Either way, you'll get the same answer. The order does not matter. Another example you may see is if I have 15 plus 12x plus 7x is the same as 7x plus the quantity of 15 plus 12x. Notice that I switched the location of my 7x. It is on the right on this side of the equal sign, and it is on the left on this side of the equal sign. It will not affect my end value. For the commutative property, order does not matter. The second one we'll take a look at is the associative property. For this one, we want to remember the word grouping. Our grouping does not matter for the associative property. So again, let's take a look at an addition example. If we have 2 plus 0 in parentheses plus 5x, I can rewrite this to say 2 plus 0 plus 5x in parentheses. Notice how in this part of it, I had 2 plus 0 in the parentheses, and on this side, I have the 0 plus 5x in parentheses. The values in parentheses changed. Let's compare this quickly to our commutative property where the parentheses did not change. For associative property, what's in our parentheses will change. Let's look at a multiplication example. We can have 2 times 0 in parentheses times 5x, which is the same as 2 times 0 times 5x. These are the same values. Even though the parentheses changed, that's our associative property. Lastly, we have a similar example to the one above. 15 plus 12x plus 7x, which is how we started earlier. But now I can rewrite it as 15 plus, I'm going to change my parentheses, 12x plus 7x. Now I change the grouping for associative property. Next, we're going to look at the identity property. For the identity property, the result is the same number. That's what you want to remember for the identity property. The result is the same number. When we do addition, we add 0, and we do multiplication, we multiply by 1. So when I do addition, if I have 5x squared and I add 0 to it, I'm going to end up with 5x squared. I'm going to end with what I started with. Same idea for multiplication, except I'm going to take that 5x squared and multiply by 1, and I end with my original 5x squared. We can also have larger quantities in parentheses. If I have x plus 3, if I take the quantity of x plus 3 and I multiply it by 1, I will end with the same thing, the quantity of x plus 3. That is my identity property. My inverse property for addition says a positive plus a negative gives me 0. And for multiplication, we look at this word reciprocals. We'll look at an example of what that means in just a second. So for addition, if I have x over 2 plus a negative x over 2, I am equal to 0. So notice how it's the positive and the negative, and they equal 0. For multiplication, this idea of a reciprocal, so if I have x over 2, just like in this example, I want to multiply it. The reciprocal means I'm going to flip or change these two positions. So if I have x on top and 2 in the bottom, I want to have 2 on top and x in the bottom. And that is going to be equal to 1. And when I look at more two-termed examples, if I have x plus 3 and I add a negative x plus 3, I get 0. That's my inverse property of addition. I'm equal to 0. So notice how you see 0 here and 0 here for inverse and identity, but notice the difference here. Addition for identity is equal to the same thing that you started with, where for inverse, it's equal to 0. So we want to make sure we note the differences between identity and inverse properties. Lastly, we're going to take a look at our distributive property. For our distributive property, we have the product of a number and a sum or difference. So what we have here is an example such as 2x plus 4. So what we're going to do when we distribute, and I encourage you to draw these arrows as you multiply. So when I distribute my 2, I multiply 2 times x to get 2x plus 2 times 4 to get 8. Anything on the outside gets distributed into my parentheses. Let's take a look at another example. Negative 3 times the quantity of x squared plus 5x. I'm going to do the same thing. I'm going to distribute into my parentheses. So I have negative 3x squared. Negative 3 times x squared is negative 3x squared. Now I'm going to distribute negative 3 times 5 is negative 15, and I have an x on my 5. So I have negative 3x squared minus 15x is what happens when I distribute this negative 3 into both terms. And lastly, I would even distribute fractions into my parentheses. If I had the example, negative 1/2 times the quantity of 2x squared minus 8x plus 10. This looks a little more complicated than our earlier examples, but you're going to use the same idea. So negative 1/2 times 2 is negative 1, but I can just write a negative, and I'm going to bring down my x squared. Negative 1/2 times 8 is positive 4, and because I have an x, positive 4x. And lastly, negative 1/2 times 10 is minus 5, and I have no x's on that, so it's just minus 5. There is my solution. So this table is a good summary of your properties. Keep it with you. We will continue to go over some examples in class.